Yeah, go ahead. Just you can give me an intro and then I'll start the presentation.
Okay.
Okay. Because all of you
Lakshmi,
wanted DSPy, I'm like putting together a deck very quickly I have the code, but
no, Lakshmi, we are most of them are hardcore here. I think even if you walk through without the slide deck would work for all of us.
okay, let's
Okay.
see. Okay, we'll
Uh,
see.
so Narasimha is like pragmatic engineering leader with over 2 decades of experience building, scaling large-scale systems. He worked core core Java technology at IBM, led high throughput platforms at eBay and Amazon, and driving critical engineering initiatives at Uber across maps and platform automation. Today, as a director of engineering at Capital One, he focuses on building scalable and reliable systems while bringing traditional software engineering with modern AI practice. Lakshmi also deeply interested in practical application of LLMs, RAG systems, bringing the hands-on, no-hype perspective on AI and engineering. Beyond his professional roles, he also actively mentor engineers in sharing his experience in system design, platform thinking, and practical AI adoption. With that, thanks Lakshmi for joining. And this is like third, and we are going strong. Thank you so much for sharing the knowledge.
Thank you, Nanda. Could you give me access to present?
Yes.
Right. In 1 minute, guys.
Now you should be able to.
Yeah, just give me a second. I'm just should be able to. Okay, I'll just share my entire desktop because we're going to shuffle between uh, presentation and code and all of this stuff. So thank you, Nanda, for the great introduction. I am no leader. I am just an engineer. So thanks a lot for taking the time on a Friday evening. I know how hard it is for many of us to find time during our busy days. As Nanda said, this is the third in the series of discussions that we have been having around large language models. For some of you who joined the last session, that is probably when we kind of started looking a little inside what happens inside a large language model. Are all the models the same? We kind of looked at some examples of how reasoning models behave very differently. What is the power of a model with a large context space? Some people say 4 billion model, 8 billion model, 16 billion models, or much more than that. Like, what do they actually mean? And how do they actually influence the outcome of the response that we get from these models? I think we also talked a little bit about how do you install models locally and run them, etc. So with that, now that we have a large language model or we are used to looking at a large language model, um, we will kind of try and understand about how do you interact with them? Are there better ways to extract information from them? What actually happens when you give a prompt? And are there structured ways in which we can extract more meaningful information from a large language model? And then we will talk a little bit about RAG to say, okay, my model is generic one. How can I make it more specific to the context that is relevant to me or my company? And towards the end, we will spend some time going over one of the frameworks that allows you to automatically come up with a right prompt for a model. In this case, today we'll specifically focus on DSPy. And we'll see how time permits. As I said, DSPy is a large topic. I know very little of it. I would be happy to have a session focused only on DSPy where we will try and go into the nuts and bolts of it. We'll see how time permits. Um, okay. With that, we will try and cover, I think we kind of talked about a little bit more about. So a quick recap, how does a large language model actually work? User gives a prompt. Now, prompt could be textual, prompt could be visual, prompt could be a code, but at the nature, they take the input, they tokenize it, and they convert these tokens into vectors, and they feed it through a series of neural nets, And the neural nets, as it progresses from one layer to the other, they continuously keep predicting what is the next likely thing to come, what is the next likely thing to come, what is the next likely thing to come. So at the core of it, a large language model is a probabilistic next token prediction engine, which uses transformer layers and some of the nice features like self-attention and all of those things to essentially build a larger context space so that it knows where it came from, and that it can predict where it needs to go. That's like a very quick intro about what happened, how do large language models actually work. Now, I actually wanted to provide an analogy on how does a large language model, which is basically a probabilistic model, arrive at an answer for a question that we ask, or predict the next line of code, or generate an image of it? How does it actually happen? At the very core of it, an LLM is supposed to decide what is the next step that I need to take at any point in time. We can influence this by kind of some of the techniques that we will see today. One is the prompts, which is the starting position of the trail. Now imagine a river where it can start at some point and end at some point. The prompt essentially focuses the LLM to get into a specific starting point of the trail. And we will see some practical examples around how different prompts change this. From there on, some of the prompting techniques help you to narrow down the path of a predictor to say, don't go here, but try to stay here, etc. And then it then tries to predict what is the next sequence, which is likely take me to the peak or the end of the river, whatever we call it. And then it basically summarizes the response that you're going to get. So prompt defines the starting position from where you will start climbing the mountain or rafting the river. Temperature tells you how much risky do I want to get in this whole journey. RAG kind of is like, yeah, signboards or direction posts in between to help the large language model steer towards one direction more specifically. Fine tuning, which is a technique which we will see in probably some future sessions, is about how do you actually go into the nuts and bolts and reshape this whole mountain that you want to climb, or reshape this whole river that I want to raft. So this was just a mental analogy for us to understand what LLMs do in a sort of a plain English terms. Okay, so as I said, the purpose of, or the basically an LLM is essentially nothing but a next token predictor. How do we control, or what are all the parameters that are available for us to control within a large language model? So the prompt, which is something which we will talk about, it controls the instructions, which basically eventually directs the behavior that we want the model to behave or do. RAG, which is the context, it talks about additional knowledge that is getting ingested into the context space of the model for it to decide which paths are more predictable than the others. Third, which is the fine-tuning aspect of it, which is Cora or LoRa, which essentially alters the internal plumbing of the model itself, which is to say, rather than taking one steps, how can it take 4 steps towards it? So that's how you essentially one of the elements of fine tuning is to say, how can I make a small language model run as effectively as a large language model? So it's like a teacher kind of teaching a student and then imparting the knowledge. So that's for a future session. Any questions so far? So this mental framework is important so that we kind of follow along, and some of the terminologies that we will see in the subsequent slides, you are able to relate to it.
So for good, Lakshmi, probably
Okay.
one session on LoRa fine-tuning would be happy to listen.
Yes, we had to
Break it.
write the 5th standard exam before getting into the 6th standard. So that's
Understood.
what I said. This is probably going to be the last session, which is mostly English, very little code. But once we get into LoRa or even some aspects of DSPy, you'll see more of code.
Okay, thank you.
Okay, all right, thanks. I see some interesting names. Raghavendra, so nice to see you after, I don't know, a decade maybe. So thank you for joining in.
Hi, Lakshmi. Yeah, nice.
All right, okay.
Right. Thanks.
So with that, let's just talk about the first aspect of how do you influence a model's behavior, which we will talk about prompt engineering. We talked about what are prompts. Prompting is the programming of the model's behavior. So obviously, same model, different prompt, different outputs. We will try and play around with it and see whether it actually happens. What does prompting actually do is it helps the model to pay attention to specific aspects of how you're asking it to do. It also, to an extent, directs how it has to reason through a problem or a task that you have given it, and kind of giving the guardrails. So I think in some of the previous slides, previous sessions, we talked about it's like giving instruction to your child. Be safe, don't go outside the community, wear a helmet, don't ride the bicycle very fast. So you put guardrails, you put controls. So these are the ways by which you influence the behavior of a large language model. But know that prompting does not necessarily add any language, add any knowledge itself to the model. It just changes how the model uses what it already knows. And many of you might have already seen this, known this. The structure of a prompt has four parts to it. One is what sort of a person do you want the model to behave like? What is the task that you want it to work upon? What are the contexts or the constraints with which it needs to operate? And lastly, how do you want it to produce the output that you want it to produce? Who, what, when, or careful, constraints, context, and then how you want the output to be. So largely, this is how we talk to different people for the same thing. We talk differently. So this is essentially that. So the goal is essentially to be able to know that each of those parameters, which is the role, the task, the context, or the constraints and the output, serves a specific way in shaping how the model responds to a task that is given to it. We'll see some examples and hopefully we'll be clear towards it. Okay. So we will use this question just so that we all kind of know how a basic model looks like, how a different prompt produces different result for the same question, etc. Okay, so we will go with this really weird question. Why did we choose eventual consistency for the order processing service instead of a strong consistency? Sounds technical. I chose this question because towards subsequent slides, you will see some aspects of RAG where we are actually giving more context to the model to be able to react in a certain way. So that's why this question is not a very generic question per se. Okay, now let's jump into a demo. Let's see how the model works here. Pardon the warning messages that you're going to see on my screen because I have not yet said something. So what I'm going to do is, again, I have a bunch of models that I have already installed via Olama. Now I'm going to choose the Llama 3 model throughout this exercise. If you guys want to look at something, I'm running on a pretty basic laptop, so even a DeepSeek takes a lot of time for me to run, or Gwen 3, though I cannot even run it on this. So I'll use Llama 3 through this demo. So Olama run Llama 3. As you can see, this itself takes time. Okay, now let's put the question to it. What is the question? Why did we choose eventual consistency for the order processing service? Why did we choose the eventual consistency for the order processing service instead of strong consistency? Sorry, I should copy this and keep it because I'm going to be running this stuff. Okay, that's fine. Let's see what it says. Now, Llama is actually a pretty good reasoning model. Again, some of you who sat through the last presentation would know that I asked various models an absurd question like, why is the Bangalore metro running under the river Kaveri? In fact, it does not. Some models just played along. They said, yeah, because it's easier to build under the river, you don't have to acquire land, blah, 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 blah. But some of the very good reasoning models, Llama is actually a very pretty balanced model, which came back and said, no, Bangalore metro does not run under the Kaveri river at all. The Kaveri river is some 80 kilometers away, and so you are wrong, sort of a thing. So I'm just taking already a sort of a decent model, and then we will ask the same question using different prompts and see how it's actually able to relate and respond back. So the question is pretty generic. So it kind of chooses some questions in OPS, one of the key considerations, system surveillance available, and then it kind of gives you a broad set of answers for why eventual consistency is better than a strong consistency. Okay, and then some sort of a generic statements in reasons why you will consider this over that, etc. So nothing fancy over here, which is a pretty, you can say that this is a pretty decent response. Now let's see if the same thing can be asked in a different way. So what we are going to now do is we are going to first introduce the role. Okay. You remember there were 4 things that we said. So now we will say, okay, we will now introduce the role and then see this, say as the same question. You are a senior software engineer, sorry, senior software architect who is reviewing a production system, and then let's just paste the same thing. So it's kind of generating a response. Do you see anything different when we introduce the role here?
So looks like the answers are more tailored towards the software development.
Yeah. Anything else? Thanks, Nanda, for that. Now, the earlier response was like generically saying where eventual consistency is good or strong consistency, etc. The moment we started forcing a role to saying that, hey, now as a senior software architect, tell me why this is important, you can see that it actually starts to bring along some aspects of architectural patterns. And then, of course, it's big time hallucinating. It's saying your system is designed to handle high volume of errors. I don't even know where it came, all of it. And then it says, from what I can gather from your code base and system design documents, I have some code, but I don't have a system design document. Of course, it does not have any high volume data or anything like that. But then it starts talking like an architect. The verbiage that it's using, the way it is structuring its response. It talks about CQRS, for example. So some of those things are how an architect would respond to a question like this. So you can see that there's a slight change in the flavor, how the same model is responding the moment you put in a context of a role. Now let's do this. Now we are essentially saying that the same thing, which is we are telling that, hey, you are a software architect who is reviewing. Why did we choose it? Now we are putting a constraint. Answer using concrete system trade-off and failure scenarios. Let's put this answer using concrete system trade-offs and failure scenarios. So now it's going a little deeper and then trying to explain in its own hallucination in some aspect trade-offs between eventual consistency and strong consistency in an architectural uh, parlance. It is obviously making up its own understanding, phrasing, and all of those things. But then you can actually see that it's saying that a strong consistency will require that every party in that node has to agree on the state of an order before updating it. And then it goes into things like order consistency. It talks about performance bottlenecks that can come with a strong consistency over here. You can see over here it says that it can lead to bottlenecks and strong performance issues as more and more order comes. Having a strong consistency would require a heavy amount of low latency orchestration across all the nodes who have to agree on the transaction. And then it then compares and says eventual consistency means multiple nodes can process orders, and then which means that you could have much better load balancing. And then it goes on to give you an example of what it thinks will be the scale at which an eventual consistency will be able to handle loads, etc. And then it compares specific aspects in a failure scenario. How would an eventual consistency work? Is it better? Is it worse, etc. And then, as you can see that when you add more context as the role, give it a little bit more constraints to operate on, the answers are slightly changing from where it started also. If you look at it generically, when I said, tell me why we made the decision of going from strong to an eventual consistency, it started from the very basics. It says in an order processing system, this is how the world looks like, etc. When you said the role of an architect, it didn't start from ground zero. It assumed that there was an architecture, there was a design that was available, and then it picked it up from there. And the path that it took was largely towards architectural patterns, etc. Now, when you said, okay, now consider failure scenarios, give me trade-offs, then it didn't start from the last point. It actually went further up ahead and then focused, assume. Okay, it started to say that this is where your patterns are failing, this is where it might actually work, etc., which is a little further up ahead, if you were to call it, along the reasoning chain. Any questions on this so far?
Very good, Lakshmi.
Okay, cool. Now we'll just add one more things. Okay, now we will say, okay, now tell me how did you arrive at this answer? We're going to introduce a chain of thought prompting to this thing to say, now explain your reasoning step by step before giving the final answer. Let's just go with that. Explain your reasoning step by step before giving final answer. Is it too hard to read from the terminal or?
It looks okay with me.
No,
I
it
think
is
it
okay.
would be better to
Yeah,
clear
it is
after
good.
every new prompt.
You want me to clear it every prompt?
Right.
And Lakshmi, is there any reason that you keep adding to that existing prompt?
So now the prompt, if you look at it, the prompt was the same thing, which is like explain why you chose this. Now we are saying, okay, now be an architect. Give me this trade-off constraints. Explain me how you arrive at this. So the output that we are, the task that we are giving it was exactly the same. But then when you gave a role for the same task, the output changed. When you added constraints, the output changed. Then we're going to add things like, okay, don't just dump the output. Tell me how you arrived at this output. So if I had removed everything, at least when you're seeing it, you might not be able to know that it is exactly the same prompt as the previous one. It's just that I'm adding a little bit more constraints or roles into this.
Okay. Adding more elements to your prompt influence the output.
Yes, that's the that's what I wanted to show.
Mm.
Hopefully it's coming out
Yeah.
clearly. Okay, let's just spend a couple of minutes understanding this. So okay, so again, I'll just do the things. We said you are a senior software engineer. Then we said, why did we choose an eventual consistency? Answer using trade-offs, explain your reasoning step by step. And then this is all pure garbage, okay? It's just hallucinating with. But then look at this. It said, when I looked at it, the first question that I asked was, why did you choose eventual consistency? So it is basically because we asked it, explain your reasoning step by step. It actually says, okay, I'm going to ask this question first. Why did you do that? And then it said, okay, then first I looked at what are the pros and cons of each of those. Okay. Then I looked at trade-offs. It's basically uh, telling you how it thought through the problem. Then it said, okay, hey, I then looked at trade-offs of scalability versus data integrity. Strong consistency will slow you down when your order volumes grow. Availability, yes. Eventual consistency is better because it doesn't, because strong consistency might have a single point of failure, so it might be better from an availability perspective. From when it comes to node failures point of it, then a strong consistency will mean everything else is blocked because one node is down, and eventual consistency will work. Partitioning, then if there is a connection in the network, then strong consistency, which means everything will have to block. So, and then it says, okay, hey, now after I looked at all of these trade-offs, I think that eventual consistency is it's a right design that was balancing it, etc. Of course, in this case, it's just trying to agree with some of our points, etc. But by giving it a chain of thought prompting, you can see that it's actually explaining things as it's walking through. Um, this is good from an explainability perspective. If you are building a model where explainability is important for either guardrails or for whatever reasons, remember that a chain of thought prompt is a good way to induce the model to tell you how it arrived at the solution that it finally proposed. If you recall, when we were looking at other reasoning models, especially DeepSeek turns out to be extremely oriented towards reasoning. So even if you had given a simple prompt, why did we choose eventual consistency over strong consistency to DeepSeek? Because it is foundationally a reasoning model, it will actually tell you, this is how I'm thinking through it. It may take a lot of time, but it will tell you first, let me look at this. Now I'm going to look at this. Oh, this is not working. Maybe I should try this. If you remember, we gave this question of how do you plan a trip for a school trip from Bangalore to Chidambaram, and then we gave a budget constraint and said, DeepSeek took a really lot of time because it was foundationally a reasoning model, and it naturally started telling about how it's thinking through the problem without we having to give it a specific prompt to explain that in detail. Clear so far?
Lakshmi, can I
Yes.
ask a question?
Yeah, Ravindra.
Right. So yeah, it is good to know more about how this works. While you are adding constraint and persona in the prompt itself, and it keeps changing. So what we generally see in the general usage is it keeps the persona in the history of your GPT transaction. Even that is gets added. In this case, if I ask this last question as a first itself, would there be a different answer?
Most of the times, yes, because in this case,
Yeah.
the context is still preserved.
Yeah.
I mean,
Right.
ideally, I can exit out of this,
Mhm.
and if I open it again, then it loses that context
Yeah.
memory.
Right.
But because within the same session, ideally, yes, I needn't have to put the whole prompt again. I could have just said, uh, explain your reasoning for coming this to conclusion. It would have closely given you what it said before.
Right.
So Lakshmi, one more thing. So in this, in- when I access the API, LLM through API, it doesn't remember the previous conversations.
You have to inject the context. Yes, because they are stateless calls.
So here because of we are using Olama has a little bit of memory. It kind of
Yeah.
I think it's not on the LLM behavior remembering the past conversation.
Yes, by default they don't.
Ah.
So there are multiple ways to do that. So there are frameworks that allow you to keep context in memory. Like Olama is a command line tool, so it's kind of having it in a memory context.
Okay.
But if you are actually building an API call to a ChatGPT or a Gemini model, then you have to inject the context. It's like it forgets what you,
Correct.
which is the capital city of India. It may say New Delhi, and say who created it. It may not
It will
know
not
what does
remember.
it mean. So you have to inject the context so that it knows this is related to the previous one.
Previous one.
Yes, there are so in a conversational, it's a classic case, right? Like when people build chatbot applications powered by large language models, this is a classical problem. So they have to keep the context memory in some place. And when there is no deterministic way that it'll always route to the same machine which answered the previous question, the context will get ingested back into the model's memory before it answers the next question. So ChatGPT by default has a context, so you can actually keep conversing with it, and then it'll know that, oh, this is related to the previous question and answer it because it's keeping it in its memory. But if you are kind of building an application of your own, it's a very important thing to keep in mind that yeah, you have to keep feeding the context and then to it.
I noticed even Gemini also remembers the context even after weeks, as long as you
Yeah,
have the session.
So
whichever
basically, that's
open.
exactly what it does, right? Like, yeah,
Yeah.
you're right. So when I go to ChatGPT, I have various projects. I have like
Yeah.
some 15 projects. So every time I load the project, it knows what was the previous conversation. So what it essentially does is it's same thing. It technically speaking, it just pushes it as a RAG. Okay. So not exactly as a RAG, but something very close to a RAG for it to know. Oh, this is the point of where we left this discussion last week. It's like putting a bookmark. After you've read 10 pages, you put a bookmark and then you open it and you start, you know, where you left it off. All right. Okay. Now the sort of the last one, which is to say, hopefully this is very clear, right? Like we introduced constraints. We said, tell me how you're thinking through this problem. Now we are going to just say, answer in 3 sections: context, decision, consequence. Let's just see if this works here. Answer in 3 sections: context, decision, and consequence. Okay. Context, decision, and consequences. I'm trying it for the first time here. I think it'll know what the previous context was. Let's see. Otherwise, we'll go back to the full prompts. And that keep me honest on time, okay?
Sure.
Okay, it's just very weird. Okay. So it knows the context. Okay, I didn't tell what we were talking about. We didn't say anything about order processing service, etc. But it kind of picked up from everything that was done before, and then now you can see that the tone has changed. Okay, it's no longer the architect's tone or anything like that. It basically said the team chose sequential consistency. I don't know why it picked up the team name. Somewhere in its memory, it realized that these things are typically done by team. And then it kind of throws some garbage saying eventual consistency has allowed the company to balance performance. We don't know why it says those things, but largely you can see that by giving it how you want the output to be structured, it kind of largely focuses on producing output in that form. Okay, now all of these things, this is a combined prompt which does all of what we said. We just added a last constraint, which is says apply theoretical explanations, avoid theoretical explanations unless they are directly applied to the system. So this is essentially what a combined prompt would look like for this case. As you can see that it gives a role of an architect. The constraint is concrete trade-off failures. reasoning it, give me step-by-step chain of thought on output structure prompting. So if we run this, I don't think it's relevant, but you can see that everything that it does, it basically will structure it and then give it in a form, which you will see will be radically different from what the first prompt gave. The first prompt was just about why did we choose eventual consistency in an order processing service. So it basically gave some generic things, right, about this, and then it get more and more refined as an architect. We say it then gave us specific architectural patterns, and then when you asked a chain of thought, it walked us through what all it considered towards coming to that conclusion. Trade-offs, we asked it to put constraints as trade-offs, and it became a little bit more better, a little bit more better. Just for the sake of this fun, let's just see what it does for you guys. So now it's taken an architect's tone. As you can see, as I reviewed this, I see that this is for a high throughput system, and then it's that the narrator in this case is actually you can see that it's an architect who's actually giving the recommendation, and then it still kind of structures its output around context and all of those things. It's doing through some of these reasoning part of it, and then it will eventually come up with a consolidated report. Let's see if it is adhering to the last prompt, which is essentially be factual and don't just throw garbage unless it is totally related to what this system is supposed to do. So while it's generating, I hope you get the message how the roles, the context, the constraints, explainability, and the output format kind of shape how the same model produces output, which is either grounded in reality, supported by factual data, in a tone that you want it to be, within the boundaries of what all do you think it should consider, it should not consider. So hopefully that this is clear now.
Yes, Lakshmi.
Cool. All right. With that, let's move on. Yeah, I know I'm very behind on time. Okay. All right. So this slide essentially says where can these prompting techniques really work? So a role prompting changes the tone and the depth. So if you want the response to be the same prompt, for example, if I say give it from a perspective of a security compliance officer, it will show very different. So if you are tuning your content for specific type of audience, then choose the role so that the content is delivered in a way that sounds well or that kind of resonates with that audience, right? Constraints forces concrete, decision-oriented responses, reduces the vagueness. Chain of thought is especially when it's relevant for teaching or evaluating a quality, like in this case I'm doing. If I give a chain of thought, then when you're teaching, then it's easier for you to say this is how you reason through the problem and you come through it. And it kind of provides some level of transparency on how the model arrived at it. Output structure is obviously in what format it's easier to consume for you to present it, reports, reviews, or wherever it's relevant. Combined is it's a high stake. Like you want to go and present it to your very senior leadership, then it's better that you kind of combine all of them together. If you are giving a recommendation, so then whatever role you are playing, you ask the response to be in the tone of the level that you are. Okay, now is the image clear?
Slightly smaller if you can.
Okay, I don't know how do I do that. Let's see.
Zoom option, something is there.
Yeah, I can zoom in. No, actually, this just messes up the zoom. Sorry. Okay, open image in new tab. Okay,
Ah,
all right. Now
okay.
this is what I wanted you guys to pay attention to. Now we say prompts. Like, what does a prompt actually do when it comes to a large language model, and how it is able to influence the outcome that we saw? So the basics of inference is you give a prompt and then it gets converted into an embedding, and this embedding goes through a series of transformer layers, which are essentially neural net layers, and then an output comes up. And then when it comes to zero shot prompting, where you're just saying classify great movie, which is a sentiment, then this is what in an inference world, this is called a shallow activation, which is the latter layers of your your neural net don't get activated. So this is because there is no context here. Most of the reasoning completes within the first few layers. So it is generally a surface knowledge, as we call it. It just only relies on what it has seen in the past and then gives you the things. When you give a few shot prompting is where you give it an example, and then you say Shawshank Redemption, great movie, or something like that. So then you're actually going into a little bit of a pattern matching mode where it then in the neural net layers, it actually progresses a little further down, tries to look for similarity scores between the examples that you gave, and then tries to come up with a reasoning for it. So in this case, the large language model is actually learning from the examples that you gave in your few short prompt to essentially arrive at an answer. Chain of thought is the deep reasoning. As I said, it basically transfers through every layer because it has to now tell you how it arrived at the whole thing, what it thought through. So this is more, as you can see, that from a neural net perspective, it goes further down along the reasoning, which is typically why chain of thought produces high quality results within the context of what the model can actually do. So without a chain of thought, as I said, it's like fantastic, good, fine, whatever is the first answer that it gets, it's typically kind of gives it. With a train of thought, it basically thinks through this problem. First this happened, and then that happened, because of that this is happening, etc. So this is how the layers within a transformer, which are essentially neural nets, get activated depending on the different types of prompts that you are giving, which is also the reason, hopefully you understand now, why a sort of a detailed prompt, the more the layers that you activate, typically the better the answer that you get. So which is why a good prompting technique goes a long way in kind of helping to draw uh, possibly not I wouldn't say the correct answer, but a well judged answer, at least from your perspective. Is this clear?
Yes. So the chain of thought you'll activate by giving some instruction within the prompt.
Yeah, exactly. In this case, for example, uh, the chain of thought essentially we said explain your reasoning. So explain your reasoning step by step before giving the final answer. Now, by doing this, we are essentially forcing sorry, man, I'm totally messing it up. Okay. You are essentially forcing the model to say, no, don't jump into the fifth step already. Walk me through how you came through to that. Okay.
Okay. So Lakshmi, one more question. So when the prompt are from the users, we cannot expect them to think through this and then they write a prompt, right? We are eventually talking from the perspective of the application developer.
Garbage
How?
in, garbage out is a unfortunate thing, but it depends. What's the trade-off? What's the cost? It's like English. Uh, if you're not able to converse using the right words, I'm not talking about a master level proficiency, then obviously your idea will get lost.
Okay.
I'm not saying that that's wrong or everybody should learn English, but any language for that matter. certain words have more power than others. How do you communicate is how, just like programming. You
Okay.
can write an extremely inefficient loop, or you could use some other way of computing for loops, which are far more faster, for example. So, okay.
All right.
I don't know if there's an answer to that, man. Okay, very quickly, prompt engineering cannot inject new knowledge. We knew that. If a model is foundationally broken, it cannot fix it. And obviously, it only relies on what the model already knows. All right, so far so good.
Yes.
Okay, now with that, let's move into the next technique, which is, okay, I have a model. It is possibly decent with some aspects of it, but there's just no context about what I am doing, etc. Can I make it aware about it? So retrieval augmented generation, as most of you know, is one of the most popular technique where you essentially inject context into the inference and the reasoning layers for driving the model behavior towards certain directions. The analogy is RAG is like the signpost that you see along climbing a mountain, which you say this side is an avalanche, don't go this side, go that side, sort of thing. So the typical process is that you build a context that you find is relevant for your domain or for your system, and that context gets stored somewhere. And when the large language model runs, the context gets ingested into the LLM, and the LLM, apart from its reasoning capability, it then looks at the context to see, hey, is this giving me better answers? Is this specifically giving me answers that think of it like a high priority queue. So it first looks there to see, is this giving me answers? Oh, if there are answers there, then I actually trust that more than what I know by myself. We will kind of see some examples later, and hopefully that will make it simpler. Okay, great. Same question. Now you know why I chose a very weird looking question, right? Why did we choose eventual consistency for order processing service instead of strong consistency? Now we knew that the model was reasoning from its general knowledge because we did not tell it anything about why we made the decision. Okay. Now we are going to actually show it the code. Let's see, where am I having that code? Sorry guys. I had to put it over here because where's that stuff? Okay. Sorry, not this one. Yes, shit. Okay, why am my memory such failing? Just give me 1 second. Where did I put it? I have to figure it out now. Okay, it's called adr.md. Okay, is it there? Okay, crap, I did not commit it. That's fine. I'll show it to you. So what I ended up creating was I created an architecture document. Okay. So this, think of it like your engineering requirement document, which your team writes, which gives context about your own engine, your own system. So it follows some basic templates, which says this ADR or whatever change request you want to call it. And then it talks about why did we choose eventual consistency for our system. So far, the model thought what generally works for order processing systems, but now we are actually making it more detailed. We are saying that, okay, my OPS order processing system works with the inventory service, payment service, notification service. And then we are saying these dependencies have variable latencies, which means that these systems have different SLAs for responding to the queries, and they can occasionally fail. And why did we do that? We have rationale over here. We said, okay, we want to focus availability over immediacy, which means we want to make sure that the system is available rather than being able to view responses or be able to process order faster. We wanted to be able to have failure isolation, which is something which the model also said that eventual consistency will help you achieve. It talks about business tolerance, something about availability again. What all did we consider but rejected? We said we rejected strong consistency via distributed transactions. Hey, can we actually send this transaction over multiple systems and process it? But then we rejected it because it required high latency, operational complexity, risk of stalls because every node has to finish processing. So as you can see, this document over here kind of gives a sort of an insider perspective on why the system was designed with a eventual consistency in mind and not a strong consistency. Clear so far? Yes?
Yes.
Okay. Okay. Now let's go into the dirty details of okay. Now unfortunately here's where we get into the code. You guys can see the screen, right?
Yes.
Yes.
Yeah.
Okay, all right. So now first thing for us is, okay, there is this document. Now I need to convert this document into a form that my large language model understands. And as many of you know by now, the first step towards this is what we call as an embedding, where we essentially convert every single word in a document or a text into embedding. And then these embeddings are stored into the context of the model, or it's actually stored in the context in the memory. So when you ask a question, all the model does is it takes your question, converts it into the same embeddings. For example, if your question is, I have, when you type I, it looks into its memory space to say, what are all the possible paths that an I can take? Then it goes to I have, you have said, okay, have, okay, it narrows down the path. And then you say, so it tries to map what are all the paths that it has in its memory which closely relate to the question that you have in mind. Very similarly here, it's going to take this whole ADR document. We are going to chunk it using a text embedding model. In this case, I'm using a mini LM model. And then these are parameters that can change. And then we are going to convert this whole document into a vector embedding and store it with us. That is all we are going to do first. Okay. And then we will see as a result of doing that, does the model output change any better? Okay, let's close the stuff. So what is the first thing here? So first thing for us to do is essentially to run this. While it runs, we can see what it does. It basically takes sentence transformer, and then it says persist the embedding in this directory. You create this collection name, and then this ADR file is the adr.md, and then it chunks it. It starts chunking it, and then it encodes this embedding, and then it keeps adding it to the collection, and then it stores it. That's all it does here. So as you can say, it has created 6 chunks from this ADR because we specified a chunk size of 500, if you remember. So it says I have chunked it into 500, and then it means 6, and then I have stored it in here. If you go into, you'll see under the Chroma DB, Chroma is essentially a vector DB. SQL3 Lite is also a format for it, and then it basically dumps some of the learnings that it has done into this folder. For now, we will not go into this. Now let's go back and say, okay, now I have a vector embedding generator out of the knowledge base that I have. How do I now pass it to the model at the time of reasoning and inference so that it learns from that first instead of learning from its own historical knowledge? So let's look at the code here. We said index, okay, ask with RAG. So the same things over here, all of these same parameters. We said, okay, now in this case, if you remember, you're first introducing, okay, what is the model LLM that we are going to use now for inferencing? So remember, this can be any model that you have. Most of these models have a compatibility with the embedding model. So I could change this to 5.3 or GPT-4o or whatever we want to change it into. You can run it with this. And then we are saying top K is essentially limiting the top 3 answers that it has, using top answers that it gets to only 3. We'll get to that. So Okay, now here's the question. Why did we choose eventual consistency for the order processing service instead of strong consistency? What would be break if we change the decision, for example? And then we are first encoding this question. We are saying that, okay, encode this query itself. Okay. And then here's the prompt. You are a senior software architect, use the funnel into the ADR, and then the context is the context, essentially the results which are taken from these documents, store, and then the question is the question that we created over here, and then we said answer the system specific reasoning. And then we are essentially feeding all of this into Olama. Now Olama is running as a HTTP client on this system. So it essentially makes an API call and then it calls Olama and tells, here is the model, the role is the user, the content is the prompt. And as you can see, temperature is essentially the riskiness. Now I have set a very low temperature, so which means we are asking it to stay grounded. Don't just hallucinate with something, and then you print the answer that you get after you pass it along. Now let's see whether it works fine. So the same model, the prompt is same. We just added one extra line. We can remove it also and see. But now we have ingested some context to say, here are my system specific documents which explain the reasoning why I chose eventual consistency over a strong consistency for my architecture. Now we will see whether the response from the same large language model changes because we have given it a context. Guys, if it's boring, if you think I should talk faster, slower, please do let me know, okay?
Lakshmi, I feel the pace is good. Can digest all the thought process that are going in.
Okay, great. Thank you.
So Lakshmi, on the time check, we are like 7:05 now, and
okay,
if
so
you plan to have the DSP.
DSPy, a lot of us are very interested in DSPy. We will do a very 1 hour session. Okay.
Sure.
But please encourage more people to come in because it takes a lot of time to prepare materials for this. I have to choose the right example, structure it in such a way. But anyways, we'll get to that. So now here's the thing. Now you can see that this is all fine. First thing it says business priorities. Okay. Now you remember it said availability over immediacy is crucial. Now you remember in the ADR we did say that availability was more important. So it kind of okay. Now it's important for me to do this. And then it also went about talking about what would be the impact of switching to a strong consistency. It says European internet latency will go. Maybe this is there in the ADR document, which says ops will have to wait for confirmation before considering an order as processed. So that's going to push up our P99 latency. System throughput during peak overloads, etc. So you can see that these are all probably for this system very critical considerations to go with an eventual consistency than a strong consistency. So rather than a generic response of why eventual consistency is good, the answer is more grounded and it's actually a lot more precise in terms of exactly the reasons why eventual consistency was specified as the default choice in the ADR document is what the model picked up and said, this is why we did. Yeah, Dijin.
Yes, sir. I just have a doubt. Like the context that I saw in the prompt template, go
Yeah.
to definition of that context. How are we getting that?
Which one?
Yeah, the context equal to dot join of result of document. So
Oh,
what
the
is
documents is essentially the storage where the embedding is stored.
okay?
So
So
this is
the
the query embedding. We are saying that query this embedding. Okay.
okay,
And then from there, choose the top K results for it. And then use the top K is set to be 3.
okay, got it. Yeah, thank you.
Okay. So very simple example to show the same prompt with additional knowledge is able to kind of give its result more grounded results. Okay. I know we are like super over time.
No, we plan to have till 7:30.
Oh,
So
okay.
we are
All right.
good, like another 20 minutes.
Oh, okay. Awesome.
I was little worried about DSPy.
Okay, you guys
Probably.
should blame Nanda. Okay, I told him we will do DSPy before also. He said,
But this is good. When without prompt and context engineering, that's a foundation, Lakshmi. We can't skip that to DSPy.
okay,
If you could, give a kickstart on DSPy, like a teaser.
sure, we'll do that. Okay, so so far we are good. So we can see that the model answer without RAG was theory heavy. It was not system aware. Just based on general knowledge. Now the same question, it talks about ops, it talks about inventory payments, it talks about what would break, but reasoning became very different because it became more grounded on your design document that it did. So hopefully this made it clear as to how RAG improves the relevance of an answer which is specific to your context. Okay, what goes on is essentially RAG improves the grounding. It makes it the model more specific. The quality of the decisions are also much more better. There's a clear explainability rather than theorizing something. It just says it. It does not make it smarter, right? At the end of the day, it's just giving additional knowledge than what it already has. It does not change the model weights. To do that, you need to go to LoRa and all of those things. We will do that. But it changes how the model reasons from and not how smart it is, very bluntly put. If you give it an additional textbook which is much better than what it had learned, it then picks it up and says, okay, my responses are going to be based on it. The risk of doing that is obviously the fact that garbage in and garbage out. So if your RAG is outdated, for example, if you're building a chat application, if the pipeline is not up to date with the most recent queries and answers, then your system while it can fall back to a default response, it might be wrong also. So building a RAG means that the pipeline, the knowledge has to be constantly refreshed so that it's more up to date. Okay. So very basically put, this is what happens in a RAG. The data gets retrieved from the vector database. It gets augmented into your into the context that it already has, and then that results and influences the generation of the output.
Lakshmi,
All right. Yeah.
quick question maybe beyond this class. This context what we are putting from what we are generating, is that something can be a common knowledge for multiple users to come in, or every time I have to put in? I mean, there will be always, I think.
Oh, you can actually store.
Yeah.
What generally companies do is they
Yeah.
create a knowledge base of their processes and stuff like that, and then it gets stored into a common database.
Right.
And then
Not the database. I'm talking about whenever you're putting this prompt with that context. I don't want to keep giving this context every time to the model. So I can add to that model.
You can say the context is stored in this file. Always load it from that file and use it also. Yes.
Thanks.
For example, the same knowledge base, you can give it to different people in your organization. A customer support representative who is actually talking to the customer might look at different aspects of that knowledge base. Let's say you put in a document that talks about how do you process refunds.
Right.
Okay. It might also give information about when do you process a refund, when is a refund not allowed. So for a customer support agent, now when do you process a refund, under what circumstances, is more important than maybe how.
Right.
But for a ops agent who's actually processing the refunds, the how is more important. So agents in this case are the programs that we are saying can be tuned to look for specific portions of the same knowledge base based on the role that they are performing.
Right.
Okay.
Yeah. Thanks.
Hey, Balaji. Yeah.
Lakshmi, and how is this different to an SLM?
To an SLM.
Yeah.
Oh, SLM is very different. What we are telling is, okay, there is basic reasoning. I keep giving this a very bad example, but pardon me. You have a professor, and the professor has 20, 30, 40 years of experience. He or she has read thousands and thousands of books, and then they have distilled the knowledge in their mind, which has considered multiple probabilities and possibilities and all of those things, etc. Okay. Now, there is a question that comes. Now, their way of reasoning through the problem might be very different. Okay. But if they could distill that knowledge and say, my reasoning steps we're moving from 1, 2, 3, 4, 5, 6, and up to 10. If you could condense those reasoning steps into, let's say, 2, if this, then that, hypothetically speaking, we can talk about it when we do the model fine tuning session, then you can tell that to a student and say, don't worry about vector differentiation, what all you need to consider. If this comes, then do this. If this comes, then do this. Now, the student may not understand why it is to be done that way, but it helps the student to arrive at an answer, hopefully faster, in this case faster because their processing space is much lesser, in a very short amount of time than what a professor, of course, a professor will also do it faster, but that's why the example is a bad example, but the processing power that you might require to arrive at an answer is very, very less. So for example, let me give a very bad example again. So let's say the question is, how do you find whether a number is divisible by 5? Okay. Now, the logical answer is divide the number by 5, get the remainder, divide it again, get the remainder, divide it again, divide it again, divide it again. Or if it's a common multiple, then figure out how many, keep on multiplying that number till you get that answer. Okay. Now, a much more short form of this is, if the last digit ends with a 5 or a 0, then the number is divisible by 5. Now, and to an SLM, it just needs to know these two decision points. All it has to check is essentially the last bit or last digit, and say if it's 0 or 5, then it does not know why. The y aspect of it is hidden from it because it's not responsible for knowing it, or it doesn't have to know it. It doesn't have the capacity to know it, but it will still arrive at the answer. Now this is how essentially a model tuning or model training actually works, where you take a large language model with a 16 billion, 32 billion, 64 billion parameters, and you train a small language model on it based on a series of question and answers. You look at the model output in terms of what it produces as weights, etc. And then you say, okay, if then this is how the model came to this conclusion. So I'll condense it and just say, if this comes, say this. I'm dumbing it down a lot. We will do a 1-hour deep dive. If people are interested, we'll do a very specific session focusing on how to do that. But largely, you kind of understand it. RAG is very different. RAG is context that does not exist. You might have the latest reasoning model with 128 GB parameters, etc. But if this is a process that only your company knows, how you process orders, how you process refund is not public knowledge, then no matter how big a reasoning model you have, it's not going to help. In fact, for those cases, a smaller reasoning model with a RAG might actually solve the problem much effectively than just going with a large language model. Okay. Okay, guys. Can we move on? Any more questions? Okay. Okay, now that we have kind of looked at different techniques for how you can influence the output manually, there are limits to that also. As you can see, there is trial and error. Many of us might have experienced it when we were generating an image with Nano Banana or even with ChatGPT. Sometimes you have to go through a lot of trial and error and stuff like that. Sometimes it's not reproducible also. It just cannot give you the result. Can I just, sorry guys, 1 minute, just give me 1 second, sorry. Sorry, of all times, my daughter had to call now and ask if her friend can play. Sorry about it. So prompt engineering and prompt tuning has its own, manual prompt tuning has its own limitations. It's sometimes not reproducible. Sometimes it's hard to measure improvements. Sometimes you can see the measurements, improvements in terms of how it comes, but you may not be able to quantify how much things have improved. Scaling across teams is an interesting thing. Like Raghavendra asked, should I put this context somewhere for everybody to use, etc. So at scale, sometimes a manual prompt tuning does not work. It works for our individual use cases, but not for everyone. So with that in mind, we will start looking at one of the frameworks that automates aspects of this prompt tuning, which is called DSPy. DSPy at the core of it is it's trying to solve an optimization problem. It basically is a software optimization which says, you say, here are my inputs, here are the outputs, here are the metrics. Metrics could be constraints, metrics could be time, all of those things, etc. And then what DSPy does is essentially kind of iteratively works through it to find out. Oh. Okay, DSPy tries to find out the better prompt that will help you get to that answer. So at a very high level, there is an input. The input is taken by the DSPy program. DSPy kind of looks and behaves like an orchestrator who then kind of iteratively calls your large language model, generates one of the prompts, feeds it into it, gets the response, looks at the response from certain aspects in terms of the evaluation metrics, and then it optimizes it. And then it essentially keeps doing it over and over again till it identifies a prompt which actually meets the evaluation criteria that you specified it to do. So which essentially might lead to an automated prompt refinement. Clear so far? Okay. Now I have an example. I don't know how we are on time. I hardly believe 10 minutes.
We have another 10 minutes, Lakshmi. I think we are good.
10 minutes might be a gross injustice to this. I can show you the demo, run the demo, and then show you what DSPy does as a magic to pique your curiosity. But then we'll have to have a far more detailed session, just unwrapping this one at a time and then seeing how it works. The example in this case is given a customer complaint. We want to classify it across either it's a billing technical problem, refund related issue, account issue, or something like that. So I have a detailed example. I have the code, but let's see. Do you want me to run the code and just show you what DSPy does, or I'm just conscious of the time that it takes. So let's see. I'm just trying to find out. Okay. I will show you how how DSPy from a coding perspective looks like and how it essentially goes about doing it. And if time permits, I'll show you the code and run it, and then we will keep the deep dives for future sessions. So a basic naive classification essentially is where you use the complaint, and then you try to just take the input field and then you display based on some prediction. You define a model, and then this model could just call a large language model, and then now you are not specifying the prompt here at all. You're only giving a ticket, and then you're asking the system to predict it, which means you're asking it to come up with its own prompt to figure out how it's going to work. So you define input output. There's no reasoning. There's no optimization. We are just calling a direct prediction for it. When you add a structured reasoning, which is like a chain of thought sort of a reasoning, what it essentially does is it takes the input, it takes it through the reasoning layers of it, and then there's a structured reasoning process through which DSPy takes this input into, and then if you remember when we talked about how chain of thought actually works, it forces the prompt to go through multiple layers within the neural net that the large language model has. The idea is that the more the layers that it passes through, the stronger the reasoning is and the better the judgment itself is. What it also does is it kind of forces the results to be far more consistent, obviously eliminating the need for a prompt engineering to be done from an external things. And you will see the outcome in probably just one line. Like you don't know what it eventually did, but if you want, we can print that. But it essentially will give you the outputs. Okay, this is one slide that I put together, which says compares the various techniques that we have to sort of improve the model response, so to speak. The primary lever for the manual prompt engineering is handwritten. For RAG is the context. DSPy is there are programs plus the optimization that the framework itself does. And then in the case of prompt engineering, only the prompt text changes, but RAG, the prompt also changes and the documents also changes. And then DSPy, the prompts are learned automatically and then iteratively refined. New knowledge only in the only RAG adds new knowledge into the LLM per se, and no none of the other two. Reasoning style is controlled by prompt, yes, but manually. RAG does control the reasoning because of the context that you're ingesting. DSPy, because you're kind of providing it with an output force function, it's a little bit more strong, and there's a more systematic way in which it kind of drives through the reasoning style. Tone and format, yes, somewhat, and then probably clear. Consistency, yes, this is also a critical thing, like Raghavendra, for your point of view. How do I guarantee that this prompt will produce the same result how many ever times that I invoke it? It's hard to kind of, because these are statistical models at the end of the day, and especially when you have to scale it across teams for them to consistently come up with the same thing. DSPy set of frameworks allow you to kind of using the cost functions and the output constraints, you indirectly hit the prompt that actually gets generated, and hence driving a more consistent output per se. Scaling, hopefully clear. Speed, fast. The prompt is fast. So just you get a response. Sometimes it could be ad hoc. RAG is faster. You can see that the context is given. Most of the times it just works fine. DSPy is not just fast, but it's also measurable. You can actually see how better things have become. Is it any evaluation driven? Hard. Manual prompts are hard to know how things improve. RAG is the same thing. DSPy, when I run it, and I will show you, it's largely metric based, etc. Risk profile, same across things. When do you use it? When you're exploring prototyping, go with prompts, manual prompts, simpler. When there's specific knowledge that is required for your reasoning model to do well, then go with RAG. DSPy, you need reliable and repeatable output quality, then DSPy could be one of the frameworks that you can consider for that scenario. What is up with this? Okay. All right. I have 4 minutes. Let's see. Let's see if I can show you the code first. DSPy. Okay, all right. So I'm going to use Llama 3. I'm running it on OLlama, so which is why you see this URL. Now, here are basically the categories. I'm saying that the various categories into which a ticket can fall into is either billing, technical, refund, account, others. Now we are just giving the raw data set, which is basically saying that I was charged twice, then it's a billing problem. The app crashed, technical, please cancel my subscription, and refund, I can't log in account. So this is a set of examples that we are giving it to the model for it to train and say, okay, when this comes, this is the output, when this comes, this is the output, etc. Now, what we are going to do is essentially, we are saying classify the support ticket into exactly one of the following. Because that's the problem statement that we are going to give it to the model. And then I'll push this code into GitHub somewhere, and then you guys can look at it when you want. The output will essentially compare the scores between a naive classification and DSPy classification. As I said, the next set of meetings will go a little deeper into what actually happens. This was more supposed to be a wow thing, Python, DSPy, LLM. Excellent. So the ticket is, the website is showing a 500 error. Okay. And then this is the baseline results. Baseline results as in, which is basically the naive predictions of it. So very interestingly, right, the baseline accuracy itself was 1, and the chain of thought accuracy for itself is 1. Now this is actually, if this craps out, then I'm really sorry. There was some bug that I couldn't get the time to fix. But here is actually where DSPy is trying to fine tune its prompts and coming up with what is the right question that I should ask the large language model, how should I structure it, etc. Sorry guys, there's some bug that I have to fix it over here. I promise you I will fix it before I push it, so that if you are cloning from my repo and running it through, you will not see this problem. I'll also, Nanda, it's on you now to set up the follow-up with DSPy, because many people are seeing it. Okay, I think with that, I'm mostly done. I don't have anything more over here. This is the, yeah, this is some techniques that we now heard. what we can do. Yes, Balaji.
Lakshmi, ideally, when you implement these in an organization, right, we need the RAG so that we can really define the context,
Yeah.
as well as the accuracy of the DSPy. How can we bring them together?
So that's a very good question, right? Now, as organizations, what's generally happening now is this role specific agents being created. As I explained to Raghavendra a little while ago, your process document could be exactly the same, but depending on the role who's looking at the document, what they infer from it could be different. So now, in the case of a DSPy, you are in the example that I showed is a classification problem. You did not tell the model anything about how do you arrive at this answer saying that please process my refund should be a refund problem. Okay, you did not say anything about it. You might have a RAG which has some things about to say that when a customer takes a subscription but cancels within the first 15 days, then they are eligible for a refund. If they're an enterprise customer, then they can cancel after 45 days, then you can give a refund. These could be policies that you could define in your RAG. Now, instead of you having to explicitly specify in a prompt saying that as a customer support representative, take this question and then come up with the right answer based on the RAG, DSPy essentially does a very simple cost optimization. It just tries to say, if this is the kind of the question, then this is the answer that I'm expecting. Now, when a customer query comes in, it essentially looks at that and then it does what is the right kind of a prompt that I have to build to get to the answer that I learned about the past. Now, this can actually be persisted, which means that you can repeatedly run the same query or the DSPy command, and it will actually produce exactly the same prediction from the model. Now, we should probably have a separate session where we will jointly explore how do these all roll up in terms of an architecture if you're trying to build an agentic first platform. At which layer does a DSPy sit in your platform? How does it actually orchestrate with the RAG data that you have? How do you kind of put it behind an agentic persona, if you want to call it that way? But largely what ends up happening is because it is how the role queries the database. So you might end up creating DSPy driven prompt engineering code for different personas in your system. But you have to obviously train it to say that this is what a CS agent is responsible for, this is what a backend agent is responsible for, etc. But given that context, it can take the RAG, it's no different. It can actually take the RAG, but then it iteratively identifies, oh, the RAG embedding looks like the path that I need to take is here. So what prompt actually drives me to get that? And then it keeps on validating it with other training sets that you have given it to it. And then comes up with a confidence score to say, yes, I have now been able to predict it with X amount of accuracy. If the code worked, then I would have been able to show you. I'm really sorry for it. But I promise we'll have one more session to have much more deeper dive on.
So, Lakshmi, if I understand slightly different with the context, is DSPy is going to help reduce my scope of space to look at in the RAG for a prompt? Basically, because if my RAG from an organization perspective or a process perspective is too large, and this prompt can go all around, and I am helping to fine tune my prompt through DSPy so that I know where I'm getting into.
Uh, No,
It's
for most of the
okay.
organizations,
Yeah.
DSPy is not better than RAG. They solve different problems. Okay.
Right.
But
Right.
RAG and DSP can coexist also, right?
Yeah. So what RAG actually does is it retrieves external documents which are not already learned by the model, and then it injects them into the prompt, and which means that now the model has, instead of it having learned only 4 chapters, it now have access to 6 chapters that it does. So the primary question that you're trying to solve is, hey, the model does not know my company proprietary data. It is just randomly coming up things because it does not have information on it. It is not up to date, for example, right? Now, what DSPi actually does is it fixes inconsistent outputs. Okay.
Yeah. Yeah.
And it actually fixes the fragility that's associated with the prompt engineering. Okay. Now, they're complementary. They're not either or sort of a thing. And where RAG, if for example, if the model is already knowing the domain, okay, which means that the model is
Yeah.
already,
Yeah.
but you find that the output is inconsistent or the accuracy is not stable.
Right.
And you want to be able to measure how things have improved, then generally for people, go with RAG first, simpler. It just immediately injects domain knowledge for you. It gives you access, it gives the model access to your proprietary documents, etc., up-to-date information, etc. Then you can actually look at DSPy to say, okay, now that the model understands my context, how can I fix inconsistency? How can I fix accuracy problems? How can I be able to systemically measure that my responses are improving over a period of time? What ends up happening is a lot of companies start with prompt engineering, then they add a few short prompts where they give examples of thing and then do it. Then they add a RAG. Then they add more RAG as the data size increases. Sometimes because the data size is now increasing, they increase the chunk size. Chunk size is essentially the context window of how much of a document gets loaded, etc. Now, the problem here, then over a period of time, the perceived accuracy of the model keeps dropping. The issue here is the problem that the prompt structure is now different because there's a larger context space. It's like if I have to go from my house to the gate, it's easier for me, just one line. But then if I have to go from here to my house to Majestic railway station, then the very different paths that I have to take. It might be more complex. I cannot just go the same way. And there's no way I can measure whether I'm doing it faster, I'm doing it better. So DSPy essentially gives you those measurements, repeatability, and as a result, better, how do I say, better optimized prompts, if you want to call it. So
Yeah.
I don't know whether I answered the question.
Yeah, I mean, I'm putting from a layman perspective, whatever the question I put as a prompt, it will end up with one of the 100 FAQs you have. I mean, that's where DSPy, I think.
Yes.
Yeah.
See, if your model is performing poorly because it does not have context, then just go with RAG first.
Yeah, right.
If your model is suffering from reasoning or inconsistency, then you bring in DSPy to kind of perfect it.
Right.
Most of the times you will need both.
Right.
For companies where proprietary data is there.
Yeah. Good.
Cool. Anything more?
This is very good, Lakshmi. I think a lot of insights, and in between you talked that bad example, but I felt it more appropriate example, especially that divisible of 5. Trying to, I felt it easy to understand on small language model. Thanks for the deep session, deep insight on this prompt engineering and context engineering, which is largely underrated. And definitely we will start having deep dive session on DSP and other topics.
Yeah, we'll do 2 at least sessions. One on model I mean, how do you build an SLM from a large language model? And definitely we will spend more time on DSPy. We'll try to bring it more clearer, more real. As I said, putting these sessions takes a lot of time.
Lot of
Nada
time.
spends hours coordinating and getting things. So it'll be super awesome if more people can come in so that the value is there
Increased.
for it. Yes.
So that brings it my another request, a quick survey of what ideal time would be easy for us as well as others to join. Would it be like Friday evening, weekdays or weekends? Any thoughts?
So right,
mean,
Saturdays,
yeah.
Saturday late mornings or around lunchtime.
Okay.
I
It could
mean,
even be like a lunch and learn, like
Mm.
people can just eat and still listen to it, right?
evening hours is good. I think it's required in my experience. I mean, somewhere getting a nudge when you get into LinkedIn or somewhere that, okay, it's there. Like it, you get lost with the rest of the work and tend to miss out. So some kind of, putting a reminder through whatever LinkedIn is helping.
Yeah, that's a pain. I mean, putting a reminder through LinkedIn, there's no way.
Yeah, right.
Unless
right,
otherwise
right.
we,
Yeah,
that is one is there. I'm trying to solve. We'll see how to creating a WhatsApp group for this and then adding more people towards is one solution. We will see how to improve on reminder. People opted, but there is no reminder. We'll try to address it.
Instead,
Others,
if you go through like a Google form, collect the
yeah.
participation, right? Then you have all the email addresses. You send an invite. That way it works better.
Yeah. Sure, I'll try that, Balaji. With meetups, I tried it. We
Okay.
will see. We'll keep experimenting. That's the only thing that we have to improve. Others through Umesh, like what would be preferred time before we close this call? Okay, all right. Thanks, Lakshmi. Thanks everyone for joining this Friday evening and then sharing the knowledge. Wonderful session. I loved it. We will continue to have this series and then also spread this news to others to join more.
Yeah. Thank you. Thanks, Lakshmi.
Thanks.
Hearing you after a long time. Yeah.
Same here, Ravindra.
Right. Yeah.
Okay, catch up, man. Bye-bye.
Bye.
Yes. Thank you, Lakshmi.
Hey,
Thank
thanks,
you.
Balaji.
Nanda.
Bye-bye. Thanks,
Bye.
guys.
Bye. Yeah.